Alright, so here is a video for day 2 of Truss calculations. And it's really just an extension of the first day. One, we still have to remember how to check if something's statically determinate. Does 2j equal m plus r? So let's do that first, because I don't even have to do the problem if that's not true. So 1, 2, 3, 4, 5, 6, 7. So I got 7 joints, right? Let me double check. 1, 2, 3, 4, 5, 6, 7. Yep. 7 joints. Members are a little harder. Let's take a second on that. Reaction forces. This one is holding that up, and it's a reaction force on joint A in the y direction, also known as our buddy Ray. This one's holding up the bridge, Rudy, RDY, and there's a sideways force because this is the pin connection over in D. Now I can actually use my common sense. Since there's a pterodactyl hitting this bridge at joint B, I do know that RDX, or redux reaction, will be going that way. So I already know. I don't have to draw it the wrong way and figure it out later. So common sense. So I got a 1,000-pound thing here. Let's say a baby elephant. An 800-pound thing here, so like maybe an adolescent rhino. And a pterodactyl hitting the bridge. I don't know why the animals are going crazy, but they are. Okay, so we're going to try to find out basically all the external forces, which would be this guy, and this guy. We're going to do that with moments, but before we do, we have to see, can we even do this problem? So I have 3 reaction forces, and then let's see how many beams we have. I got to make sure I don't miss any. I'm going along the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Does 11 plus 3 equal 2 times 7? Boom! Doing this problem. Sweet. Okay, let's do this problem then. Okay. Now, I have to see all the wrenches. First of all, I have to pick my pivot point. And since I'm not masochistic, I'm going to pick this one, because I don't want to just punish myself. And then we got lots of wrenches going on. So here's the key, though. If I want to start finding these, I have to realize that the sum of all the moments that go clockwise better equal the sum of all the moments that go counterclockwise. So I'm going to look at this and I'm going to go, okay, which ones of these are spinning clockwise? So you got to like see your wrenches, right? So I don't have to check these two because they have 0. Let's check this one. So I got a wrench. This wrench right here is trying to twist down. That would be a counterclockwise wrench. So I'm going to put it on this side. This blue wrench here. So it's trying to twist the bridge that way. I would take the force, 800 pounds, times its perpendicular distance, so it's going down, so I want its sideways distance, of 5 feet. Okay. There's another wrench going that way. I'll make it pink here. So we're going to say, okay, this pink wrench goes to the middle. It's also twisting down. Okay, so I have a pink wrench that's twisting counterclockwise, so that's positive, right? And that's 1,000 pounds times its perpendicular distance. Now, since it's a down force, I need its sideways distance of 11 feet. Okay, and then I get all the way out to Ray. We'll make Ray a yellow wrench. Woo! And Ray is fighting the good fight here. Ray is twisting up that way. So he's going to fight those two. So Ray's going to go on this side of the equation. So I'm going to have Ray times its distance from the pivot point. So that's 5 and 6 and 6 and 5, which is 22 feet. See how I have my units on there? And then we have one last thing. This is the trickiest of the bunch, because you got to see this weird shaped wrench. I think I've run out of wrench colors. Aha! I did not run out of wrench colors. I got a purple. Okay, so my last wrench, this is looking kind of trippy over there. Alright, so my last wrench is up here. So if I drew a wrench in here, It's going this way and this way. It's one of those L-shaped wrenches that you guys love. I know. So now, which way is that spinning? It's spinning, if you push sideways on it, it's going to try to spin the bridge that way. So that is a clockwise, so it goes on this side of the equation. Sometimes you have a bunch on both sides or a bunch on one side. Anyway, this is a pretty cool problem. So my purple wrench is trying to twist this way. It's an L-shaped wrench, and I need the 200 pounds times its perpendicular distance. So if it's a sideways force, I need its up and down distance, which is 10 feet. Okay, and now I just math it, and I should be able to find out the one missing thing, which is Ray. Right, so this is 2,000 foot-pounds plus Ray times 22 feet equals 800 times 5. What's that going to be? 4,000 foot-pounds. Right? And then here, I'm going to do that, so 11,000 foot-pounds. Okay, let me get a calculator because the division's going to get weird here. Alright, so we have 15,000 foot-pounds over here. So I add those two together. And that's still Ray times 22 feet plus 2,000 foot-pounds. So I'm going to take away 2,000 foot-pounds from both sides. And we'll have Ray times 22 feet. So take away the 2,000 there, and I get 1,300 or 13,000 foot-pounds. So I keep my units the whole time. And now, if I want to get Ray by itself, I divide by 22 feet. And we'll go 13,000 1 by 22 gives us 590.91. So Ray equals 590.91 pounds. Okay, so that's one of my answers. But we're not done. We can get the other answers now. So Ray is 590.91. The other ones here, I already know I can find RDX, redux here, because to find all the other ones, after you do all that work with the twisting forces, then you basically have to just remember that your sum of your ups has to equal, FUP has to equal down. I don't know how to say that. Anyway, so my ups have to equal my downs, and my lefts have to equal the rights. Okay, so the cool, easy one to get here is RDX, because if you look on this whole picture, there's only one force pushing right and only one force pushing left. So if my lefts have to equal my rights, my RDX has to equal 200 pounds. There's another answer. Boom. Easy peasy, right? That one was easy. One more, RDY. Well, the good news is my ups must equal my downs. So if I look at this, I have two ups. I just figured out what that one was, right? And I have two downs. So RDY has to go together with RAY. So Rudy and Ray are teaming up. So I'm going to have my 590.91 pounds plus Rudy equals my 1,000 plus my 800 for my rhino and baby elephant. And then, you know, you got 1,800 minus 590, and Rudy, let's see what that's going to be. 1,800. 1,800. Then we're going to minus 590.91. I think 2 decimal places is fine. We don't need to go any further than that. 1209.09 pounds. And now I've found all the external forces. You'll notice later on we got to find all the forces on inside the beams. But right now we're just finding all the forces acting outside. So I got these pushing up, this pushing in, those pulling down, that pushing over. Woo! That was big time, man. Okay, so with that, you can probably, I'm going to put this blank worksheet online and see if you can try that. And then at the bottom, I put a little review here. I put another video that should help. It was like review from that warm-up. I went over that warm-up. But basically, these are the skills, the 2 skills we have to have in our brain for our next step. Our next step is when we start going after the internal forces on a truss. So we've only been focused on forces acting on the outside of a bridge. Next, we're going to actually start looking into the forces inside the beams and stuff. All right, so if you practice this, print this out, then I'm going to put it online, and then, yeah, try it. It's not going to be bad. All right, talk to you later.